Okay, so section 7.4, day 2 notes. So if you haven't already, take out your notes, turn to section 7.4, day 2, and copy down this essential question. How do you find the asymptote of the graph of a logarithm just by looking at the equation? If you need to pause while you write this down, please do so now. Okay, so I copied this out of the book. So parent functions for logarithmic graphs. So this was your function that we had for exponentials when we had g of x is b to the x power. Remember yesterday I told you that a logarithm is just the inverse of an exponential function. And so that's why they drew this dashed line in here, because that's the y equals x line. So if I take this exponential and reflect the points over the y equals x line, it will give me this logarithmic curve. So the curves for logs are still going to be your exponential curve, but instead of having a horizontal asymptote like the exponential function did, now we're going to have a vertical asymptote. So this is going to be the ones in red are your log functions. It's just an exponential function on its side. So now we're going to have vertical asymptotes, straight up and down asymptotes, instead of the horizontal asymptotes that we had with exponential functions. Okay, and then we'll see what that does with domain and range when we graph here, but it does give you some information down here about domain and range. Okay, so if you have one of the newer calculators, the one that has a CX at the top, then yours is kind of arranged like a computer. You can actually type this log in exactly as you see it, and it will graph it for you, and you can come up with tables. Now, if you have a TI-83 or a TI-84, then you are going to have to do what I'm about to show you by hand, okay? So if it's in log form, I'm going to change this to exponential form to make it more user-friendly. So we talked about this yesterday, so log base 3, so then my base is going to be 3. These guys split up, so that's going to be to the y power, and that's going to equal the stuff inside the log, which is x. So now we have an x equals equation instead of a y equals equation. We're not doing an inverse or anything like that. We're just changing this to the exponential form. So now I'm going to make a table of at least 3 values. Now we usually type in or put in some numbers for x, so choose numbers for x and then plug it into the equation so that we can get its corresponding y value. We're not going to do that this time. What we're going to do is pick values for y, plug it into this exponential form, and then that will give me my value of x. So typically, I'll usually for y, I'll just pick -1, 0, and 1. You can pick some other values if you'd like, but that's what I'm going to stick with. So then I'm going to take each of these y values, plug them into this exponential form so I can get its corresponding x value. So I'm going to plug in -1 for y, and you can type this in your calculator if you would like. 3 to the -1 power is going to be 1/3. Or if you put it in your calculator and it gives you 0.33, that's fine. Now I'm going to plug in 0 for y. So 3 to the 0 power is 1. And then I'm going to plug in 1 for the y. So 3 to the first power is going to be 3. So that's how I come up with my table of values. First took this log form, changed it to exponential form using the definition. Then I'm going to pick values of y, which I picked -1, 0, and 1. Plug it into the exponential form so then I can get the corresponding x's. Now I have 3 ordered pairs that I can graph. So the first one I go over 1/3 and then down 1. For the next one I go to the right 1 and don't go up or down for 1, 0, and then 3, 1. So there's my 3 points graph. Now remember we talked at the very beginning in section 7172 that how we find our asymptote when it's in exponential form, it's whatever comes after the exponent stuff. So in this equation, I have x equals 3 to the y, and then there's nothing after the exponent. So that means my asymptote is going to be 0. The only difference is that since this equation equals x, then my asymptote, instead of being y equals 0, is going to be an x equals 0. Because this curve is going to get closer and closer to this asymptote line, which happens to be the y-axis, which goes through x equals 0. So that's the change from logarithms. Even when you change it into the exponential form, it's still going to have an asymptote that's vertical, which is x equals some number. And that number is still going to be whatever is after the exponent stuff when you change it to exponent form. So then draw in your curve. And remember, you can't cross the asymptote, it just gets closer and closer to that. So this is an exponential on its side. Now looking at the graph, we can do domain and range. Now this time, we are not using all real numbers for domain. We're restricted. We're only using the x values to the right of this asymptote. So you're going to take whatever the asymptote is. So for domain, we're going to have x and 0. But then we have to decide if it's greater than or less than. Okay, because remember, domain is the x's, so I'm just stealing this stuff from the asymptote and putting it up in the domain. Now I'm only using the y or the x values to the right, so then that is going to be the domain as x is greater than 0, because I'm only using the x values to the right of this vertical asymptote. Now range this time, this is going on forever this way, and this is going to continue to get wider and wider and use all these y values up here as well. So now range is going to be all real numbers for log functions. Okay. Now this makes sense that this is flipped from what the exponentials were. When we graphed in section 7.1 and 7.2, it was the domain that was all real numbers and the range that had some restrictions. And in the exponential functions, the range matched whatever this asymptote was with y equals. Well, now it's flipped of that. Now range is going to be all real numbers for the logarithms. And then it's the domain that's going to have some restrictions. Okay, so let's try another one. So now let's look at part B. So again, I'm going to change this to exponential form. So the base is 1/2. And since it's a fraction, I'm going to put it in parentheses. So these guys split up, so it's 1/2 to the y power equals what's in the log, which is x. Okay, now I'm going to do my table of values, but I'm going to pick for y instead of my x. So I'm going to pick -1, 0, 1 again. Oh. Not sure what that was. Those are usually my go-to points for this type of problem. So if I plug -1 in here, so I'll do 1/2 to the -1 power, and again you can type that in your calculator if you'd like, but that's going to give you a value of 2, because remember the negative exponent does the reciprocal, and then it's to the first power. Now plug 0 in for y, so 1/2 to the 0 power, that's going to be 1, and then plug in 1 for the y value. So 1/2 to the first power is going to be 1/2 or 0.5. So that's how we get our table. Okay, now I'm going to plot these points. So I go right 2, down 1, right 1, and then 1/2 over, and then up 1. Now again, to get my asymptote, since it's an exponential form here, I look after the exponent stuff. Okay, so there's nothing after the exponent stuff on the left-hand side of the equation, so that means my asymptote is x equals 0. And it's x equals 0 because now I have x alone on this side of the equation. So then your vertical asymptote, which is your dashed line, is going to end up being the y-axis, because that's where x equals 0 is. So then you draw in your curve. So there's your graph. So I want at least 3 points for your graph. Okay, now let's do domain and range. Okay, so domain is your x values. So since our asymptote is x equals 0, then I'm going to use x and 0 as my domain. And my indicator that this goes in the domain is because of the variable x. So the domain is your x's. Now you look here, and then you ask yourself, am I using the x values to the right of the asymptote or to the left of the asymptote? Since the graph is only on the right side of the asymptote, that means this is when x is greater than 0. And then our range for log functions like this will always be all real numbers because we will eventually use all the y values. Now, as I go through this, if you missed something and you would like to go back, you can easily just rewind this back a little bit and go back over something that you missed. Okay, so since it's a recording, you can do that. Okay, so now let's talk about translations. Translations is when we shift things right, left, up, or down. Okay, so here you can have something inside the log with x, so x plus something or x minus something. That means we're moving right or left, h units, whatever that is. And if there is something after the log, the k value, that tells you if you shift vertically, meaning up or down. Now we just talked about this, but this basically is kind of helping you answer the essential question. The asymptote for a log function is going to be a vertical line, and it's always the vertical line x equals whatever that h value is inside the parentheses inside the log. So if you need to pause to record this stuff down and be able to write it down, go ahead. All right, so let's do one of these examples. Again, those of you with the really new calculators that say CX at the top, you will be able to type this in, look at your table, get some points to graph, and be able to do that. You don't have to do what I'm about to show. Those of you that have a TI-83 or a TI-84, then your best bet is to change this into exponential form. So log base 1/3, so that means I'm going to have 1/3 as my base, raised to the y power, and that's going to equal this x minus 3 business. Okay, now we want to get x alone over here, so I'm going to add this 3 over. So then this is now going to be 1/3 raised to the y power plus 3 equals x. Okay, so that's just taking this original problem, changing it into into exponential form, and getting x by itself. All right, now I'm going to make a table. Now remember, you're going to pick values for y to plug in, and I'm still going to do -1, 0, and 1. You can do something different if you'd like. So then I'm going to plug in each of these. Now I'm out of time for this one, so you'll stop this and then click on video number 2 for section 7.4 day 2 notes.